Hey students, people who were studied in organic chemistry, it's time to put your knowledge to application, right? So here we have top 50 inorganic questions you must solve before you are going to examination. So let's test how much you know or whether you have to revise the concept or not. Okay, so without any further delay, let's get started with the then 0.02 moles of this complex and 0.02 moles of the another sulfate complex are present in 200 cc of a solution X. The number of moles of the precipitate Y and Z are there formed when the solution X is treated with the excess silver nitrate, okay, and excess barium chloride, or respectively. Okay, the question may be given as 0.02 moles and blah blah blah, but it is very simple question. If you know the simple trick, they just mentioned silver nitrate and barium chloride, and if you could see in the complex we have the counter ions as chlorine and sulfate. Silver nitrate is for chlorine and barium chloride is for sulfate, isn't it? We very well know about the tests of these. So how many chloride ions will be there? 0.02 moles. How many sulfate ions will be there? 0.02 moles. So what would be our answer? 0.02, 0.02. So option A will be the right answer to this question. Okay, 1 second. 2 chlorides are there. So which means 0.04 and 0.02. Right. So don't miss out any numbers over there. Sorry for the confusion. Let's move on to the next question. Which one of the following is an inner orbital complexes well as diamagnetic in behavior? Okay, this question deals with the exceptional case. Right? From what exception? Here you can see the options all are having amine as a ligand. Amine is a weak field or strong field ligand. We are saying that is a weak field ligand. Okay, it's almost neutral towards weak field, so we are taking it as a weak field ligand. They are asking inner orbital complex, which means that D2sp3 hybridization, isn't it? Let's take for zinc 2 plus, so D10, chromium 3 plus, which will make you D3, right? And cobalt 3 plus, cobalt is 27, so 3D7, 3 plus means 3D6, and nickel 2 plus, which will be D8. Among this, the exceptional case in for cobalt. Why I am saying that exceptional? Here, cobalt, let's say it is forming, there are 6 electrons. Amine is acting as a strong field ligand over there so that it can pair up and then do the hybridization of D2sp3, and also that is diamagnetic. Why not, ma'am? Why not in chromium? See, chromium I'm having D3, right? I'm erasing this. Chromium I'm having D3. So which means if that is getting paired up also, this structure will be like this. The hybridization becomes D3sp2. Is there any hybridization like this? No, right? So that's why it is not acting for chromium, and zinc that is having fully filled, and what about nickel that is not also working out. So please remember, in this case, this is an exceptional case. The question can be asked from this. It was asked also. Then octahedral complex of the metal ion M3 plus with 4 monodentate ligands L1, L2, L3, L4. Observe the wavelength in the region of green, red, green, yellow and blue. Okay, great. So they are asking increasing order of ligand strength. Okay, they have given the wavelength and asking you to find the ligand strength. How you can go with this type of question? So first let me write the colors. So first one is red, followed by green, and then yellow, and then blue. So what is the relation between strength and wavelength? So we know the formula E is equal to h nu by lambda, or hc by lambda is equal to h mu, which will become hc by lambda, right? So which means E increases, lambda decreases, and vice versa. If I'm writing VibGR, let's say I'm writing VibGR over here, what is the order? Which will have more wavelength? Of course, our R will have more wavelength, which means violet will have less wavelength and more energy. Correct? So more energy, that would be start from violet, then indigo, blue, green, yellow, orange, red. So which color do we have? Not violet, not indigo, not blue. Do we have blue? Yes. So L4 must be greater. Then comes green, that is L2. Then comes yellow, that is L3. Then our red, that is L1. So which means option B is the right answer to this question. You can expect these kind of questions. Okay. The total number of isomers for a square planar complex. Okay. What kind of complex is this? This is ABCD type, right? ABCD type. So these type of complexes will have 3 geometrical isomers, right? In the list I have given you, you must have memorized that. You must have understood and memorized that. So 3, but 3 is not in the option. Then what would be the right answer? Here you have to check with one thing. They are not asking about general geometrical or any optical isomers. They are asking about total number of isomers. And here we are having ambident nucleophile, which means that one at a time, but 2 corners are there, 2 atoms, elements can donate. So S can also donate, N can also donate. Similarly, in NO2, O can also donate, N can also donate, right? So in that case, how many isomers it can give? 4 different types of isomers in case of structural. So into 3 for each one of these A, B, C, D structure. So answer becomes 12, right? This question is from asking for the bond angles. Let's see H2S, ammonia. We have H2S, ammonia, and water. Okay, so H2S, how many lone pairs are there? We can solve this question using VCPR. So if I'm talking about the bond angles based on the lone pairs they're having 2 bond pairs, and the bond angle becomes 92 degrees to 96, and for ammonia it became 107, and for water that is 104.5. It's the effect of the lone pair present in there because of the repulsion, right? So what would be the right answer? Ammonia would be the highest, then comes water, then comes H2S, which is asking for 3 isomers including optical isomers. Okay, so all these options are having 6 as a coordination number, which means these are octahedral complexes. Upon comparing these, you can see this will exhibit facial and meridional, and this will also show cis and trans isomers. And in option D, you can see this will exhibit cis and trans and 1 optical isomer as well. The cis will show D and N. So total of 3 isomers possible for option D. Then identify an incorrect statement among the following. The magnetic moment of MnCl4 2- is higher than that of FeCN6 3-. Here I'm having 2+ oxidation state, and this is 3d5, and here I'm having 3+ oxidation state, so which means 3d5, but Cn, which is a strong ligand to the pair up, so MnCl4, which will have more number of unpaired electrons, which means more of magnetic moment. This is a correct option, correct statement. And d block elements show irregular electronic configurations in some cases. That is also true. And lanthanum hydroxide is more basic than lutetium hydroxide. So which is also a correct statement. And talking about Ce4+, they have mentioned that it's a poor reducing agent. But Ce4 plus, cerium 4 plus is a good oxidizing agent. It's actually a good oxidizing agent because it is in 2 plus, which itself can reduce to oxidize others to Cu2 plus state. So which is the right answer to this question? And which of the following halides of group 13 elements is the most covalent? So the covalent character increases with decrease in electronegativity. If I'm moving from group 13 elements, so thallium, which will have the least electronegativity. So option to this question becomes TLI3. Lezine's test for nitrogen in an organic compound gives the Prussian blue color is because of which coordination compound has been formed. So this I have told you so many times. It's because of the coordination complex is option C. This question is talking about ionic mobility of alkali metal ions in aqueous solution follows the order. Okay, the key is that usually if they are asking about ionic mobility, which is related to size, right? Smaller the ion, more easily it can move. But here they are asking for aqueous solution. That is our key. So in aqueous solution means we have to consider smaller hydrated ionic radius. Hydrated ionic radius leads to more ionic mobility. Here you can see lithium is smaller, right? Lithium is smaller in size, but while it is doing the hydration, while it is connected with the water, this ion form a greater hydration, which means the hydrated radius will become more. So which makes the right answer to this question is rubidium, and then potassium, sodium and lithium. Stability of pleasant oxidation state increases in the sequence. Okay. So the stability of pleasant oxidation state increases down the group because of inner pair effect, isn't it? So reluctance of the s electron to donate or participate in the reaction. So because of inner pair effect, the stability of pleasant oxidation state increases. So which one would be the right answer? Aluminium is becoming least. So aluminium, gallium, indium, thallium. Correct order of thermal stability of the carbonates alkaline earth metal is. Okay, this question was asked in previous year question paper. Thermal stability increases down the group because of the cation size increases, right? And also it will lead to the increase in polarizing power as well, not decrease in polarizing power as well. So what would be the right answer to this question? So here we have barium, beryllium, magnesium, strontium. So answer to this question becomes beryllium becomes least, and then magnesium, calcium, strontium and barium. Geometry of IF7 molecule. So IF7, if you are calculating it, 7 plus 7 into 7, 49, which is equal to 56 divided by 8. So which is divisible by 8. There are no reminders, so which means there are no lone pairs. So 56 divided by 8, which will become 7. 7 on bond pairs. So it is not octahedral, obviously not. What about pentagonal, pyramidal? Is it a square pyramidal? Square pyramidal is for 5. Octahedral is for 6. Trigonal, pyramidal is for again 5. The answer to this question is pentagonal, pyramidal. Then which of the following compounds has the highest degree of ionic character? So among the given options, MgCl2 has the highest ionic character. Why? Because of large electronegativity, right? And also the difference is because of the differences between magnesium and chlorine electronegativity. Then which of the following species has bond order of 2.5? So if you are asking about the bond order, we know very well that bond order which is equal to bonding electrons minus antibonding electrons divided by 2 or 1 by 2 of this. So which becomes O2 plus, which is having 11 electrons. So which is less than 14. So the bond order becomes 8 electron in the bonding electron as a bonding electron and 3 electrons for anti-bonding. So which makes it 5 by 3 equal to 2.5. So O2 we know that is 2 and remaining things we already know about that. Then hybridization and shape of XeF4. These are quick questions, you can answer it very quickly. Hybridization of XeF4, Xe that is for 8 and then 4 into 7 which is 28, 28 plus 8 which is 36 divided by 8. 4 as a quotient plus 4 as a remainder, 4 by 2 which is 2. Then 4 bond pairs, 2 lone pairs. Correct. So which would be, let's see for first bond pairs XeF4. So which would be either square planar or tetrahedral. Right. So which would be sp3d2 for 4 plus 2 configuration. Then which is the correct order of ionization enthalpy of boron, phosphorus, sulfur and fluorine? So ionization enthalpy, what will happen? Increases from left to right in the period, correct, because of effective nuclear charge, and decreases down the group. So by considering this, can you tell me what would be the answer to this question? Right, you can just put ionization enthalpy and tell me the order. Okay, so let's move on to the next question, that is IUPAC's nomenclature of this complex. Let's quickly do about this. Which is the cation? Complex is our cation. The counter ion becomes chloride. Okay. And how many ligands are there? 6 ligands are there, and out of that 4 is a amine ligand. So tetraamine dichlorido, right? So which means option B is not our right answer. Option D is also not right. Dichlorido. What would be the oxidation state? So oxidation state either 2 or 3. Here I am having amine ligand. Please remember. So CONH3 4 Cl2, and here I am having the plus, the counter ion, which is only 1 Cl. So which makes it amine ligand is a neutral ligand, and remaining I am having 2 and then plus 1. So X plus 0 plus 2 into minus 1 equal to 1, which makes it 1 plus 2, that is 3. So answer to this question is option A. How many geometrical isomers possible for A3B3 type? Only they are asking for the geometrical isomer, that is facial and meridional isomer. This isomer is different and unique, so that's why examiner is more towards this type of questions. So answer to this question is option A. Coordination number of the oxidation state and the oxidation state of central metal. Coordination number, of course, that is 6. So what would be our oxidation state? 6, and here I'm having 4 minus, isn't it? So which makes it 2. Option A is our right answer. Then which of the following complex will show optical isomerism? So optical isomerism, as you can see, this is A6 type, this is A3B3, not showing any optical isomerism, and then here I'm having AA3, which is octahedral, and this is A4. So this octahedral compound and then bidentate ligand, which is exhibiting optical isomerism. Please check out that list, guys. That will be very much useful to you. Maybe I'll link the inorganic 1-hour crash course. There you can get everything about the isomerism part in below 5 minutes. In the complex of nickel carbonyl, the oxidation state of nickel, you can close your eyes and answer to this question, guys. Carbonyl complex means always the oxidation state is 0. So either A or D. What is the hybridization of nickel? So here I'm carbonyl, which is a strong field ligand. Nickel, 0 oxidation state. So D8, 4 is 3D8, 4 is 2. So what would be our hybridization then? It will follow DsP2 or sp3. It will undergo pair up, so it will form sp3 hybridization. Magnetic moment of cobalt F6. So cobalt 3 plus, which makes 3d6 4s0, right? So F is a weak field ligand, okay. And how many lone pair of electrons are there? 1, 2, 3, 4, and then 5, 6. So remaining, I'm having 4 lone pairs, which makes 4.9 bm. I already told you number of lone pair of electrons which will be there in the before the decimal point number. Okay. Then which of the following complexes is diamagnetic in nature? So you could see copper, the John Taylor distortion come over here, and then nickel complex. They're asking about diamagnetic, just to check for a strong field ligand, so which can undergo para. So the answer to this question becomes FeCN6. The complex ion which exhibits, okay, we already solved this one, which is in diamagnetic. Either the option C or D would be the right answer. D2sp3 or sp3d2. So I already told you this is a strong field ligand. So what that will do, this will do the para. So the oxidation state is 2 plus, so 3d6. So 3d6 means it will get filled the remaining 1, 2, 3, 4, 5, 6. Remaining I'm having D2sp3. That is answer to the discussion. And which of the following molecules contains polar bonds but a non-polar molecule? Polar bonds but a non-polar molecule. So polar bonds are formed between which are having high electronegativity difference, right? So in that case, what would be our right answer? Come on quick, let's check out BF3. Okay, BF3 is having boron and fluorine. Fluorine is having highest electronegativity. What kind of structure it is forming? It is forming trigonal planar, right? Like this. So, and this is having 120-degree bond angle, which is pretty big when we are comparing with others. Ammonia, you see, it is forming like this with a lone pair, and H2O also, the bend structure will be there, that is around 1 or 7, and SO2 also, that is also having a lone pairs in it, right? So in case of BF3, it is not having any lone pair, it will have a empty orbital also. So BF3, that is having a polar bond, but that is not a non-polar because of these bonds, so will get cancelled out. The polarity will get cancelled out. This question, which is talking about which of the following complex has a square planar geometry. Square planar means it is DsP2, isn't it? So check for the one which is having a strong field ligand, because that should get paired up, then only that will get filled, right? So here all are nickel only. So let's take it for the ligand. Cobalt, that is having, so not cobalt, nickel, that is having carbonyl ligand. So the oxidation state becomes 0. So 3d8 4s2. Here the oxidation state is +2. So 3d8 only. And here also 3d8, but this is a weak field ligand. This is also a weak field ligand. And once again 3d8. So in this case, it will not form a DsP2 hybridization, but here you can see after pairing it up, it can form DsP2 configuration. So answer to this question is nickel Cn 4 times 2 minus. So here you can see the question which is asking for highest magnetic moment value. So if they are asking for highest magnetic moments, means more the number of unpaired electrons, isn't it? So more the number of unpaired electrons, more will be the magnetic moment. So check for the one which is having a not having any strong field ligand. Strong field ligand only para, right? So either the option A or C would be the right answer. So A, that is having aqua, that is Fe 2 plus, and C, that is having Fe 3 plus, right? So in this case, this is 3d5 and this is 3d6. So which will have highest magnetic moment value? Fe Aqua 6 times 3 plus. Then moving on to the next question. Which of the following statements incorrect about the transition elements? They show variable oxidation state, that is true. Most of their compounds are colored, that is also true. And they form the complexes due to the presence of vacant d orbitals. Okay. Then their atomic radii decrease significantly across the period compared to S block elements. So what would be the answer to this question? So the atomic radii increases down the group, right? So that is our answer to this question. Correct order of reducing power of the metals. Okay. So when the reducing power increases, so reducing power generally decreases across the period. And why is it so? Because of increase in ionization energy, right? So considering that, titanium, chromium, iron, copper, which will have more reducing power. So titanium 22, chromium 24, 26, copper 29. So which will have more reducing power? The order is option A. Among D block elements, the one that does not show variable oxidation states. Manganese, of course not. What about iron? +2 and +3 oxidation state it can exhibit. And what about vanadium? Vanadium, the electronic configuration is 3d3, 4s2. So it can show +2 oxidation state as well and +5 oxidation state as well. What about scandium? 3d1, 4s2, which will show +3 oxidation state. That would be the more stable for this state, for scandium. Electronic configuration of chromium. Very simplest question, but you can ask this fatafat questions. Which is after argon 3d5, 4s1. Contraction is due to increasing nuclear charge and poor shielding effect of 4f. Okay, decreasing nuclear charge and poor shielding effect of 4f electrons, increasing nuclear charge and effective shielding by 4f, and decreasing nuclear charge or effective shielding by 4f electrons. So which should be right? The 4f electrons are poorly shielding, so that's why the nuclear charge is becoming increases. That's why the size is getting smaller. The contraction happens. So answer to this question becomes increasing nuclear charge because of poor shielding of 4f electron. Most common oxidation state of lanthanides, that is, of course, our +3 oxidation state. Which elements is present in an impurity in monazite? Silver 1 oxide is soluble, which is a big metal and which should be soluble in HNO3, because with silver oxide, HNO3 is forming silver nitrate. Okay. Then which of the following statements is not correct about diborane? So diborane, you know, right? B2H6, very important compound. So how would be the structure is, which is having a Bernoulli bond, right? So it has a 4 terminal and 2 bridging hydrogen atoms. Yes. And it has 3 center 2 electron bond. That's what we are calling it as Bernoulli bond. 3C2E bond. And terminal BH bonds are stronger than the bridging BH bonds. That is also true. And it has a planar B2H6 structure. It is having the bridges which is not a planar one. So answer to this question. Among the following, identify the species with an incomplete octet around the central atom. We already discussed which are having complete or incomplete or a octet and excess of octet electrons, right? Which will have incomplete octet? Of course, our BF3, that is having a vacant orbit. This is having 6, not 8. When heated with sodium hydroxide solution, the white phosphorus gives. It will give P4 with NaOH plus 3H2O. That will give PH3 and 3NaH2PO2. So which makes phosphine and NaH2PO4 as your right answer. Correct statement regarding XeF6 is, so XeF6 has a distorted octahedral structure due to lone pair bond pair repulsion. Yes, that is true. And is a perfect octahedral structures with lone pair? No, that is not true. And which is having a square planar structure? Obviously not. XeF6 has 7 electron pairs around Xe, with all pairs are equivalent. It is having only 6 electron pairs. There has 6 bond pairs, and how many lone pairs it is having? Let's check it. 8 plus 6, 7. That is 42. 50 divided by 8, 6 plus 1. So all the pairs are equivalent. No, it is not equivalent. It is having distorted octahedral structure. Which of the following elements form an amphoteric oxide? So amphoteric oxide, straightly you can tick the option of aluminium, because Al2O3, which is amphoteric, reacting with both acid and bases. Which undergoes disproportionation reaction? Disproportionation means oxidation and reduction both, the same element. So by seeing the options, you can see Cl2, which can exhibit varying oxidation states, so which can undergo oxidation and reduction as well. Let's say I'm taking Cl2 with NaOH. It will form NaCl, which is having a -1 oxidation state, and here I'm having 0, by the way, and which is forming NaClO and H2O. Here the oxidation state is in ClO minus, which is having plus -2 equal to -1, X becomes +1 oxidation state. So Cl2 is our right answer. The maximum covalency exhibited by sulfur. So very simple question. Tick the answer, grab your marks. So remember SF6. Okay. Then correct order of acidic strength. So the correct order of acidic strength, here I'm having HClO, HClO2, HClO3. So check for the oxidation state. So number of oxygen atom increases, the OH bond becomes weaker, right? So that the H plus donation will be more easier. So the more the number of oxygen atom. So more the number of oxygen atom, the weaker the bond, H plus donation will be easier. So the answer to this question becomes HClO, then comes HClO2, then O3 and O4. Which of the following molecules or ions does not have resonance structures? Ozone will have. What about BF3? So BF3, which is not having a complete octet, and that is having a back bonding, and all the atoms doesn't need any resonance. Correct order of electron affinity values. Electron affinity decreases while moving in the group. So but there is an exception of fluorine and chlorine cases. So chlorine becomes more electron affinity because of optimal atomic size. Fluorine, that is having very smaller in size and high electron repulsion. Right? So which makes chlorine take the first position. This kind of exceptional case questions you can expect. And among the following, the compound with the lowest melting point. Okay, so all are ionic. Yes, calcium oxide, magnesium oxide, barium and beryllium. But what about some covalent character in it? When the covalent character rises because of electronegativity difference, and which makes it highly polarizable, highly polarized one. Right? If you could see beryllium and oxygen. So which is having a high electronegativity difference and leading to low melting point compared to other alkyne earth oxides. The ionic radius of which of the following is minimum? Ionic radius. So you can see aluminium, that is 3 plus oxidation state, potassium, more shells are there. Aluminium, which is becoming 10. This is also 10, this is also 10. So potassium is not in our count. Comparing sodium, magnesium and aluminium, 3 plus charge is there on aluminium, which makes it the effective nuclear charge is high because the positive charge is high. So which makes the radius smaller. And the answer to this question is aluminium. The coordination number of the oxidation state of chromium here. So chromium, which is in oxalato, right? So that is having oxalato, that is a bidentate ligand. And so what about the coordination number? That would be 6. So that will tell you the answer. If you want, you can go about with the oxidation state as well. That is 3 plus. That's it about today, guys. Hope you have got a good knowledge about what type of questions can be asked. We have solved the previous year questions along with some important, most anticipated question for this year as well. So physical chemistry questions are also lined up. So please be attentive, please stay tuned, please practice more and more problems. Thank you.